Alright guys, today we are going to look at what we call dilations. So this is actually the 8th grade part of something that we've actually already been talking about, which is called our scale factors, using our scale factors and similar figures, okay? So when we've talked about the similar figures, that's actually the 7th grade concept. The dilations are actually going to be the 8th grade part. So in that 7th grade pre-AP math, we're learning both all of 8th grade math and the other half of 7th grade. So let's go ahead and look into some vocabulary and talk about some things that we actually already know. So let's see what we're going to do. So what a dilation is either when a figure becomes smaller or larger. Okay? It is the same shape but a different size. We're going to talk about the one time it's not a different size, so something to think about. So if something's a dilation, think about with similar figures, what we've talked about in the past with the scale factor between 0 and 1. That means it's going to be getting smaller. If it's a scale factor bigger than 1, it's going to be a larger shape, and we'll prove that here with the math. If it preserves congruence, that means your scale factor was 1, so you actually have the same exact shape and the same exact size. But for the most part, we're going to talk about dilations, about either getting smaller or larger. So what we need to know is that it does not preserve congruence. And what that means is that since the shape is becoming a different size, it's not the exact same size of the shape. Again, if your scale factor is 1, then that's going to be a congruent shape, but we're not going to be talking about that with dilations. That's more so with similar figures. So again, we've talked about scale factor in the past, and scale factor is a number that makes the figure either larger or smaller. And with scale factor, we're using only multiplication. So this is something that we've talked about. If you looked at one triangle and you went to a second triangle and it looked like you divided the sides by 2, you're actually multiplying by 1/2. If you went from one rectangle to a second rectangle and you can see with their corresponding sides that you divided by 4, you're actually multiplying by 1/4. Remember, dividing is the same thing as multiplying by the reciprocal. Okay? And we are going to only use this with multiplication. That is the operation for scale factor. If it's division, that's actually called factor of change. Okay? And scale factors can be actually all types of numbers. They can be these whole numbers, they can be percents, they can be decimals, and they can actually be fractions. Most commonly, we're used to seeing it as a whole number or a decimal. So we can review how to change a percent to a decimal and how to change a fraction to a decimal. So if something is enlargement, think about it. Think about your multiplication table. If you're multiplying to get bigger, you're multiplying by more than 1. So if it's an enlargement, your scale factor is going to be larger or greater than 1. If it's a reduction, we'll stop and think about it. Not only when I multiply do I get bigger, sometimes when I multiply, my product actually gets smaller. And I get smaller when it's between 0 and 1. So for example, if I multiply something by 0, that just gives me 0. That's called zero product property. But if I multiply something by 5/10, which is the same thing as 1/2, I actually take half that amount. Okay? So it has to be between greater than 0 but less than 1. If it's something bigger than 1, you're going to be getting a bigger number. Okay? And we'll have some examples today as well. So we can find scale factor by first, these are your steps. So I'm going to write that over here. These are the steps we're going to take. Kind of messed that up. I almost wrote an R. See, these are the steps we're going to take. First, we're going to write a fraction where our numerator is the new image that we're looking at, and the denominator is the original image. Again, this will make more sense once we have some examples together. Okay? So this is why we talked about with corresponding sides and corresponding angles, kind of making sure we knew where they were in the picture. Then we can simplify. Your new image will always be indicated with an apostrophe. Okay? That apostrophe looks like a little comma hanging up in the air. So what I like to do to kind of help me out is I always write it like this. Let me write it in a different color so you guys can see it. For me, I like to say new, my apostrophe over my original. So that kind of helps me out when we see these pictures. When you have that apostrophe, that actually represents your new shape, what was dilated. Okay, well, the final product of what the dilation looks like. Your original amount is what was dilated, what you started with. And we don't say new apostrophe here in mathematics with this signals. We call that a prime. Okay? And we'll talk about how you can actually dilate more than once later on. Okay? And then, in our next couple lessons, we'll actually talk about the letter that we use for this scale factor. So that's all coming up. Okay? So this is our very, very important vocabulary. So now we need to do some examples that you might see later on to help you guys out. All right, so using this vocabulary, let me show you with some pictures. So if you have some pictures and we have our steps, okay, we have our steps right here. We're first going to write a fraction. We're going to simplify, and then that new image is indicated with that apostrophe. So sometimes they're going to tell you the scale factor, but I'm going to show you what to do when you need to figure the scale factor out. Okay? So in these directions it says, what is the scale factor for the dilation shown below if the origin is the center of dilation? And all this means is that we didn't dilate it and then move it. Okay? So they were dilated around the same center of origin. So first, we're going to pick one point, and then its new point. So when we write our fraction, remember it's going to be the new image. And I like to write my apostrophe, that new prime, compared to the original. So there's a couple of ways we can go around doing this. Okay? We have this A, B, C, D. Okay? Then we have A prime, B prime, C prime, D prime. So dilations are actually just similar figures. How are they dilated? So if you actually think about it, whenever you've gone to the doctor, if you had to go to the eye doctor, they dilate your eyes, the pupil, to make it bigger so that they can see if they're healthy and what's going on. And then they're going to reduce and get down smaller back to what they normally look like. Your eyes actually dilate like that with changing of light too. So just kind of something to think about. That's in the real world what's happening. So really and truly, what we can look at is you're going to pick any one of these points. So one ordered pair, essentially. So I'm just going to look at A. So I'm going to say A. I'm going to get my ordered pair. And I'm going to compare it to its new image. So I'm going to show you how we're going to write this fraction. So X and then Y. So X is 0 and Y is 4. And then A prime, so I'm looking at this one right here. When X is 0, Y is 8. Okay? So here's what we have to think about. We need to write a fraction comparing these two. Well, if I take my new X value and compare it to my original X value, 0 divided by 0 can't happen. So what I like to do over here is say, okay, these are the two numbers I can compare. I can compare my Y values because they are different. The X values are the same. So my new, so I'm going to say new, I'm going to put an A prime compared to A, and I'm going to compare their Y values. Okay? So when A prime Y, the value of Y with A prime was 8, the value of Y for the original ordered pair was 4, so there's 8 divided by 4 is 2, so my scale factor is 2. Then if I look back at my notes, if the scale factor is larger than 1, which 2 is larger than 1, this means it is an enlargement. That means that this new image is double inside of the original. Now let me just prove it to you with another ordered pair, just so you can see this a different way. Okay? Let's look at this ordered pair D, and I'll use a different color. So if I'm comparing, it's always going to be new to original or to old, however you want to call it, what you started with. Well, now I'm going to compare D. So I'm going to say D prime compared to D. So if I need my ordered pairs for that, put these up here. My original ordered pair for D, when X was 4, Y was 0. And for D prime, when X was 8, Y was 0. So here again, you have to stop and think about it. Can I compare their y values in this one? No, because they're the same number. So we have to compare the x. So when I write this out, just to kind of help me out, I'm going to say d prime for my x value and d for my original x value for that. Okay, just something to think about as strategies to help you out. So d prime, my new image, my x value was 8, and my original x value was 4. And see, that's the same thing. 8 divided by 4 is 2. So basically, we can see that this was dilated by a scale factor of 2. We took all of these ordered pairs and we doubled them to get to these new ordered pairs. Okay? So that's what you're going to need to do on these next two when you have those graphs. So in order for you to know if it's new based on the picture, you have to look for that apostrophe. Okay? And again, reach out to us if you need help. That's what we're here for, but we want you to try them out. So let's look at what happens when they just list the ordered pairs. Let's see what happens with this. It says, given the point and its image, determine the scale factor. Pick x or y in both fractions. And what that means is if I compare a x over here to this a prime, I'm not going to compare the x value of 3 to this y value of 15. You have to pick both x's or both y's, because you're talking about that specific point of how it was dilated. Okay, so let's look at this. We always know it's going to be new prime over original, or some people write new over old, however you want to write it. I just highly suggest writing that apostrophe because it makes sure you know that's what you look at. So see right here, we want one of those digits first, okay, as our numerator. And I'm just going to use 15 because it's a nice clean whole number. Well, if I'm saying a prime to a, and I want to use my y value here, again, this is something else I do just to really help me out so I'm not mixing the wrong numbers in the wrong spot. So the new value of the y was 15, and the original value of y was 6. Okay? So that's 15 over 6. We can leave 15 over 6 just like that. In this one, they want me to write it as a fraction and simplify. So I could divide by 3 and get 5 over 2, 5 halves. That would be okay. But what if this was multiple choice and we didn't have 5 halves, 5 to 2 as a answer? Well, remember with fractions, you can just say numerator divided by denominator, going back to how we can write our fractions 3 different ways. We can write it like that. Not fractions, I'm sorry. We can represent division 3 different ways. So if I said 5 divided by 2, you can use a calculator, or you can do old school. 2 times 2 is 4. Subtract, bring up the decimal, bring this down, and 5 times 2 is 10. So if 5 to 2 or 15 to 6 wasn't an answer, they might give you 2 and 5/10. So technically all 3 of these are correct, but just depending on what your answer choices look like. Okay, so we could say 15 to 6 was correct, we could say 5 to 2 was correct, or we could say 2 and 5/10. Okay, well now, if that's my scale factor, check this out. If we know that that's my scale factor, and we compared our y values, I'm just going to show you with the calculator, show you what happened. My original x was 3. If my scale factor is a number I'm multiplying, so I'm multiplying 2.5, look, there's your x value right there, 7.5. So that's another way you can check it after you solve it. Okay. Now the last one I want to go through with you, I'm not going to solve this one, I'm just going to solve this one just to refresh your memory, because this I'm going to relate to something we did up here. So it says find the scale factor as a decimal. Okay, determine whether the scale factor produces an enlargement or reduction. Oh, speaking of which, 2 and 5/10 is greater than 1. So if it asks, this is an enlargement. Remember, greater than 1 is an enlargement. Between 0 and 1 is a reduction. Okay, so in case you guys forgot, 85%, well, percent means out of 100. So that's 85 divided by 100. Or you just read 85 hundredths. This is why we don't want you to just say 0.85. 8 is in the tens place, 5 is in the hundredths place. So that's how you could prove it. Or you can even say 85 divided by 100 is 85 hundredths. The other way you can remember what we taught you in 6th grade, when you're changing from percent to decimal, you drop the percent sign. 85 is a whole number, and when you drop the percent sign, you're going to go 2 times to the left, because when you divide by 100, that's moving your decimal 2 times to the left. So a couple of different ways that we've taught you. So 85 hundredths is going to be my scale factor as a decimal, and the type of dilation means, is it a reduction or an enlargement? Well, this is between 0 and 1, so this is going to be a reduction. Because stop and think about it, I'll prove it to you. If I have the number 3, that's what I start with. If I multiply by 85 hundredths, my product gets smaller, so it's being reduced. Okay? That's why when we say multiplication doesn't always make a bigger number. If you're multiplying between 0 and 1, it's actually going to give you a smaller number. If you're multiplying by something bigger than 1, it's going to give you a bigger number. So this last one I'm not going to solve for you. It's kind of like what we did up here. If they're going from fraction to decimal, that's what I just set up. Numerator divided by denominator, numerator divided by denominator, or numerator divided by denominator. All 3 of these mean the same form of division. So on this one, you're going to do 9 divided by 4. So think about how you would use that, either by doing long division like we did up here, or even using your calculator. All right, guys, so that's what we're working on this assignment. So making sure we know that vocabulary and everything of that nature. And again, just let us know if you need help. Good luck.